Howdy, that's a screenshot from an elderly video I did a year ago. Medicane hurling up off the coast of Portugal. This was a year ago. I was making a few videos about Medicanes, and later on I even made videos about Balticanes, like Baltic Sea, which is here. So, there was news today, and I was surprised. It's written wrongly. Google translated it from me. Heavy hurricanes threaten in autumn due to the heated Mediterranean Sea. With temperatures of or up to 30 degrees Celsius, the Mediterranean Sea is significantly warmer than in previous years. Meteorologists therefore expect severe storms in autumn, so-called Medicanes, which are similar to hurricanes. Yeah, we won't make a whole read through to that. That's just the second screenshot I did. And here's the translation to it. That's what's about. The warm water temperature of the Mediterranean make tropical cyclones likely in autumn. These are so-called Medicanes. These have occurred in the past, but are likely to become more severe in the future. Yes, Balticanes, at least as far as I know, haven't occurred yet. But let's see. There's hardly any cooling on land these days, and the water is also warm. Temperatures of up to 30 degrees Celsius are currently being reported from the Tyrrhenian Sea, part of the Mediterranean Sea. That's 2 or 3 degrees more than usual, according to meteorologist Claudio Tei from the National Science Council to the DPA. This does not bode well for the coming months, because from the warm water temperature of 26 or 27 degrees, so-called Medicanes develop in the Mediterranean Sea. The conditions for the formation of such storms are currently ideal. That's a paper from the National Academy of Sciences. The Earth's electrical environment, telluric currents, the natural environment, and interactions with man-made systems. And here I want to point one thing out. There is this channel of what I have been talking about once, which I will show you in another picture again. Figure 16.1. Planetary scale distribution of telluric currents according to Gish at 1800 GMT. And I'm not exactly sure if it's 1936 or just a page, I don't know, or number, picture number. Could carry currents flowing in the entire region over which the relatively short lengths of wire extended. In this case, the pipe network was the receiving antenna, even more than the lengths of wire. Recent evidence of the effect of telluric currents integrated over a planetary scale has been provided by analysis of Maxat data. Langell, 1982, reported an analysis of the data in terms of separation by spherical harmonic expansion of the external and internal origin geomagnetic field. what I was in elderly videos trying to explain, if this is Earth with its layers, there is one layer where is the water. And this will either expand or what's the opposite of expand? Yeah, it will do the opposite of expanding. Decrease? No. Anyway, it's about the charge. And either, if the charge is more, it will expand. As said in the Bible, water was coming out of the ground. If it gets lower, it will contract. Yeah, that's probably the word. So the groundwater will go inside the rock, inside Earth. Or the opposite? That's the question. I don't know. But if the charge changes, the charge potential which goes through Earth in both directions, we have the Birkeland currents here. If this is changing the overall charge of Earth, the water bubble will do its thing. It will expand or detract or whatever the opposite is. I forgot it again. But anyway, let's continue with this. Spherical harmonic expansion. Of the external and internal origin of geomagnetic field, the analysis was done for different sets of data depending on the value of the DST index, a measure of the particle ring current in the Earth's magnetosphere, and, therefore, of the level of disturbance of the geomagnetic field. Figures 1630A and 1630B show the lowest order and degree terms, i.e. dipole terms, denoted as such GI and QEY, I don't know what they are meaning, and external and internal respectively change with the level of DST. I don't know what DST is. Do we find any clue here? That's a very long paper. We are at page 250. So I think it is explained somewhere. I think it's just the energy flow which goes into Earth. The internal term increases with decreasing DST, unlike GI, a consequence of the fact that induced currents must flow in the direction opposite to the inducing currents. Summarizing, accurate knowledge of telluric current patterns in the Earth on a planetary scale still remains a basically open problem, even though the subject has a long history. In addition to the actual role of ocean water and sediments, largely unknown is the influence of localized conductivity anomalies, such as fault belts, mid-oceanic ridges and trenches and subduction zones, and such patterns. The current patterns will obviously be different from different periods of the external inducing field. The higher frequency patterns will be highly time variable because of the temporal and spatial variability of the external original fields. Variabilities that are not yet amenable to accurate predictive modeling. Nevertheless, giving all the foregoing caveats, We present in the following sections additional discussions of many of the relevant issues, as well as some implications for practical concerns. And yes, as I said, that's a long paper. I will put a link below. You can download it for free, the whole paper. But where has it been? Here. Localized conductivity anomalies. In addition, the actual role of oceanism is the influence of localized conductivity anomalies. Do you follow me? Remember this. Localized surface conductivity anomalies. You have seen this before. There's weather coming into Scandinavia. It made already damage in Sweden, approximately here, and it will hang around over Scandinavia for 2 days. Expected are even tornadoes in Finland. Heavy rain, winds, water devils, water sprouts, or however they are called, trombi in Finnish, and tornadoes. There was a warning for tornadoes in Finland. Okay, so that's the original screenshot. Original. Actually, it's not. No, it's not. Because if it would be the original, we could click here on go to website. But it's not. Let me check out if I find the original. So that's the original screenshot, amongst some other screenshots. And let me take my old color. Go to the website. Let's go to the website. EPOS EU.org, geomagnetic field between Earth's core and space. How geomagnetic. EPOS, European Plate Observing System. The requested page could not be found. Page not found. Contact us. Yes, I did. And this is what happened. But anyway, let's go back to the picture since we have it. So that's the picture. I tried to put it on Google Earth to make it fit as good as I can, since I cannot make overlays. And I tried to expand and I played around with some lines and stuff, and I think this is the one I like the most. This is positive, and that's negative. So they have to spin in a certain direction. Of course, they will be overpowered every now and then. They will experience also this kind of total opposite polarity switch. And here we have it again, this channel, which we have seen on this other map. And that's a surface conductivity anomaly. A big one in Northern Europe. And I think this is heavenly, heavily influencing weather patterns. Because here we have the Kursk magnetic anomaly. MA, Kursk magnetic anomaly, which is very strong. And now we have in the news Medicanes. And I wouldn't be surprised if we would get this kind of Balticane too here. Balticane. at one point. Let's have a quick look at windy and then I will stop here. And actually, before we go to windy, that's a screenshot I once made. Here in the middle, we have the Siberian traps and the polar vortex, which is spinning around those. No one really talks about the Siberian traps. I made many videos about those because I think they're very important in regards to pole shift weather patterns and all these kind of things. Sun cycles. But anyway, let's go to windy. I haven't really watched it today, so let's see if there's anything. And let's give it a second to load. Let's start at the equator. This might be Sahara sand, or might be not. There has been this kind of, I made a video about this when the equatorial, there was this kind of gap and it started to go north. And I don't know if this is now what happened to that. Then here we have a discharge southwards from the equator. Near the South America magnetic anomaly. So, is there anything of interest? Usually I watch like this kind of loop several times in a row in order to recognize some patterns. And it somehow seems that we are connected to the equator. There's an energy flow from the equator and also from the Azores. Seems to be going into the same direction. And let's put on the pressure lines, then we can see the high and low pressures. Pressure isolines. So at the moment, the high pressure system is here, and here is the Kursk magnetic anomaly. So if we go over to the wind patterns and such, this might move into this location again. Maybe it's wandering around a bit as well. Yeah, and here it's almost like sunny. There are like high clouds there, but it's really hot. Wind. And now we get the pressure lines. Now let's see where this high pressure system is moving towards. How does it evolve? I think at one point it will try to get to this location again, where the Kursk magnetic anomaly is connected to the surface conductivity anomaly of Scandinavia. There will be a high pressure system. Like I said earlier, every now and then they get overpowered and they change. They wobble around, everything is moving, it's alive. Earth is alive. Now we are into Tuesday, And there's already a small high pressure system. And it's approximately in the place where I told you. Check it out. Okay. This is what I'm talking about when I show you this picture. So here we have Finland, St. Petersburg. That's the Swedish coastline. Actually, I drew it wrong. Here it goes. The Baltic, and that's the Swedish. And if we go back to windy, we are almost at the exact position of that. So it does influence the weather. And that's why there's a channel which channels the weather up there. And if we go back again, once again, then I will leave it. Maybe I have to make, where is it, a bigger version of it here. And that might be also the reason why we have one of the heaviest storms usually in this region. Because there's the boundary between plus and minus. And there has been, in the last few weeks, thunderstorms very close to us, but not exactly where we are. I'm here somewhere, where it's red. That's why we don't have thunderstorms. And that's why everything is so dry. But it seems to get overpowered over the weekend. Let's see how much here goes down. Is there any tornadoes or whatsoever they were talking about in the news? In eastern Finland? Or I think they are mostly here happening. Because the region of the surface conductivity here is so big, it will strongly interact. And furthermore, there is the border between plus and minus. And if you watch at this picture here, just how it looks with the blues and the reds. And if you take a look at the polar cusps, cusp reconnection, it has a similar, very many similarities. Cusp reconnection. And these are really far out in space. They're up here, and you are somewhere down here. So, maybe this C-pinch-like structure here, surface conductivity anomaly, might even be an ancient North Pole. Yeah, why not? Now here you can see the better. They have striking similarities. So studying geology is not only studying weather, it's always also studying space weather. So, if space weather can make these kind of things on Earth, so it will have very strong influences onto your mental health and all other health issues, because we are made out of light. The spark within us will react to the electromagnetic fields in which we all are, the whole planet, everyone. You cannot escape. So it's important to understand that they are very important things. They forge history. And people have been trying to warn us about these kind of events with petroglyphs and stories about people on ships crashing into mountains and stuff like that. The water, the heavens, lightning. We are up to a big event, so it's going to be very interesting. Thanks.